Hello, people of geometry. Welcome to 7.4, talking about inscribed angles. And let's just start with what does it mean to be inscribed? And all inscribed means is that if I have a circle and I have a point on a circle, any angle I create where my end point of my angle is on the circle, that's inscribed. Okay, so this angle in here would be considered inscribed. Okay, that would be an inscribed angle. Okay, so now why is that important? So in inscribed angles, kind of just as it says here, vertex on the circle, sides that contain chords of the circle. So chords, as always, just two endpoints on the circle. You have a vertex where the two chords meet, so this would be considered an inscribed angle. So this would be the angle. This part out here would be my intercepted arc. Okay, so this is the intercepted arc. Just kind of the part that gets cut off by the angle. Okay, so now why is this important? Well, let's think about what we've talked about before. We talked about central angles before. Okay, so central angle, we start at the center. Central angles go out, their endpoints are on the circle, their vertex is the center of the circle. And we said that, whatever angle measure this was the same. So like if this was 34 degrees, this was also 34 degrees, and so on and so forth. So how does that change for an inscribed angle? For an inscribed angle, it ends up being half of the intercepted arc. Okay, it ends up being half the intercepted arc. So if I said that this was 68 degrees, then if I just kind of create the central angle would also be 68 degrees. This angle in here would then be 34 degrees. Okay, that's kind of how that works. This is going to be, this intercepted arc is going to be half of the inscribed angle, and vice versa. The inscribed angle is going to be half of the arc. Okay, so now let's take a look. So here we have angle P. Angle P is right here. Okay, this is an inscribed angle. This is 70, so this is going to be 70 divided by 2, so it's just going to be 35 degrees. C is this angle right here. I'm on number 3 right now. So if you look, CD, CE, so that inscribed angle, that intercepted arc rather, is 98 degrees. So I want that divided by 2. That's going to equal 49 degrees. And that's my answer. That's my answer. So flip that around down here for number 2, and I get PQ. So that will be 56 times 2. That's going to be 112 degrees. And then CF, if you look, you have this angle and this angle, it's 40 degrees. So it'll just be 40 times 2, which will be 80 degrees. Okay? Sometimes they're a little trickier to follow. So, kind of off of that idea, so it should make sense that if I've got an inscribed angle, and I've got another inscribed angle that intercepts the same arc. Okay, so you see how they both intercept. This is my intercepted arc both times. When I do that, so I'm going to fix that line. Since they both intercept the same arc, it would make sense that these two are going to be equal to each other. Okay, they both intercept the same arc, which means they both have to be half of this. So it makes sense that the angles are congruent. So if this was 80, both of those would have to be 40. That would be my answer. Okay? So now let's put this into practice a little bit. So as you can see, T intercepts SV, U intercepts SV. So we're going to go 3x minus 5 equals 2x plus 15. They're going to be equal to each other. They intercept the same arc, so they're equal to each other. So add 5. So x was equal 20, but we're not done. They want to figure out what angle T is. So I just want to substitute that in there. I get 55. I hope I'm right. For number 6, number 6 flips this around. Number 6 says S is 3x. V is x plus 16. Figure out how big S is. So now if you look, that intercepts the arc TU. So those two are going to be equal to each other. 2x equals 16. X will equal 8. So to figure out S, I merely want 3 times 8. And I'm going to get 24. There's my answer. Okay, so if they intercept the same arc, then they're going to be equal to each other. Okay, so now if I've got, so now expand this idea a little bit. So if I've got a triangle inside of a circle, it's completely inscribed. So now if you look, angle G here, this angle inscribes, okay, intercepts the whole semicircle. Okay, semicircle is 180 degrees, which means that's going to be 90 degrees. Okay, and it goes back and forth. So it cuts at the diameter, which makes it a right angle. If this is a right angle, then it cuts in at the diameter. Okay, so if it's strictly at the diameter, at the middle, or through the middle 2 endpoints, then it's going to be a 90-degree angle. So if I look, I've got this situation. I know that this is 90, which means, you know, a triangle still has to add up to 180 degrees. That hasn't changed since, like, first unit. So 4x plus 2 plus 9x minus 3 will equal 90, because I know this is 90. So 13x minus 1, 13x equals 91, divide by 13. X should equal 7. X will equal 7, but they're looking for angle F. So I need 4 times 7 plus 2, so that should give me 30. Okay, move on. If you have a quadrilateral inscribed in a circle, that means all 4 points touch the circle, all 4 of the vertices of the quadrilateral touch the circle, then the opposite angles are supplementary. So if I have this situation, these two are opposite, they're going to be supplementary. These two are opposite, they're going to be supplementary. Supplementary, fancy way of saying, adds up to 180 degrees. So these two and these two, when it's inside of a circle, okay, not just a regular quadrilateral parallelogram, when it's inside of a circle, they're going to be supplementary. So if you consider here, you know that these two, okay, you know that this is 90. You know that these two have to be supplementary because they're inside of a circle. So 3x add 30 equals 210. So x will equal 70. All right, so that makes that 70. That makes that 140 minus 30, so that makes that 110. So you know it's got to be 360, so that one's also going to be 90. So measure of angle A is 90, measure of angle B is going to be 110. Likewise here, those two will be supplementary. Those two will be supplementary. So x plus 60 equals 180, so x will equal 120. And 95 plus y will equal 180. So that would be 85. And that's my answer. Those are my answers. Okay? You're still playing around with this idea that any 4-sided figure's got to add up to 360 degrees. And you're just kind of saying, hey, what happens if I put that inside a circle? That's all you're doing. Okay, so now get going on your assignment, see what you can do, play around with some of these ideas, and I look forward to your questions.